Welcome to the part 2 of module 4 functions, that is scopes. Thus far we have discussed basic function definitions and calls. As we saw, Python's basic function model is simple to use, but the simplest function example also quickly lead us to questions about the meaning of variables in our code. This video moves on to present the clarifications and solutions for those questions. So here we and I'm gonna present Python scopes. The places, scopes are the places where variables are defined and looked up. As we will see, the place where a name is assigned in our code is crucial to determining that what the name means. So when you use a name in a program, Python creates, changes, or looks up the name in what is known as namespace. Namespace is a space where names live. The term scope refers to a namespace, that is, the location of a name's assignment in your code determines the scope of the name's visibility to your code. In all cases, the scope of a variable where it can be used, literally in a layman's language, the scope of a variable is nothing but where it can be used, is always determined by where it is assigned in your source code and has nothing to do with which functions call which. Now let us explore the different scopes available for the names. Names defined inside a def can only be seen by the code within that def. You cannot even refer to such names from outside the function. These names are known as local to that function. If a variable is assigned inside an enclosing def, it is non-local to nested functions. If a variable is assigned outside all the defs, it is global to the entire file. It is high level code. If that code is high level, it is a global one. So now, if the prior section sounds confusing, it really boils down to three simple rules with a def statement. First one, name references search at most 4 scopes: local, then enclosing functions, if any, then global, and finally built-in. This is what we called name resolution scheme. L local, E enclosing, G global, B built-in, LEGB rule. So name assignments create or change local names by default. Global and non-local declarations map assigned names to enclosing module and function scopes. Still confusing? And are you overwhelmed with bewilderment? Just give me few more minutes. I will make it much more simpler. So, a name references search at most four scopes that we have discussed. What are those four scopes? Local, then enclosing functions, if any exist. If not, then it will go to global, and finally it look in built-in namespace. Yes. So now let us take a simple example. So you mentioned some variable name which is not assigned to any object. So that's what so we mentioned some variable name which is not assigned to any object. So this is called as an unqualified name. When you use this kind of unqualified name inside a function, Python searches up to four scopes. I hope you got what I'm speaking. For example, if you take any file, in that file we have x is equals to 5 and y is equals to 6 and all. So that means this x and y global name space where these were actually qualified, because you have referenced that name with certain object. If you don't reference any object to certain name, and if you want to use that name, then it is unqualified, because it is not it is not connected with any object. So when you have such unqualified scope, unqualified name, then Python searches up to four scopes. Let us see how the journey takes place, that searching up into four scopes, how that takes place. So basically it begins with local scope, capital L, the local scope or local to that function. So those are the names assigned in any way within a function. Either it is a def or lambda, and not declared from inner to outer. So that's where it will look into. The first scope, this is the first scope. And then it searches for local scopes of any enclosing defs and lambdas. There are the names, these are the names in the local scope of any and all enclosing functions from inner to outer. So then, and the third place to search is global scope. These are the names assigned at the top level of a module file or declared global in a def within the file. So, and then the last place to search is the built-in scope. These are the names pre-assigned in the built-in names and module, such as open, range, len, math, zip, map, etc. And finally, it stops at the place the name is found. If the name is not found during the search, Python reports an error. Python reports an error. So the important point to note down here is, when you assign a name in a function, Python always creates or changes the name in the local scope unless it is declared to be global or non-local in that function. So when you assign a name outside of any function that is at the top level of a module file, uh, the local scope is same as the global scope, the module's namespace. So with this, we actually understood how scopes work, how scopes will be helpful, and how Python, how when an program is being executed at that moment, how this Python searches for the names that you have mentioned in your program from one level to another, from local, enclosing, global, and then built-in. If nowhere it founds, and finally it makes an error, it throws an error. Okay, and here are some of the examples. For the first one is scope example, and second one is built-in scope. For scope example, see, I have told you the high level code, the high level code, whichever you write in high level, that is a global scope. X99 is a global scope. And um, here capital Y is local, and Z is local and function. So we will discuss, we'll do this using modules, that VS Code as well as Jupyter Notebook. These are built-in scope. If you just import built-ins and find out the built-ins, you will find this built-ins. What all namespace of built-in. And nested scope, there is one more example. We'll code it and we'll see. So to see the how these scopes work in reality, we will we will enter into a directory. In that directory, using VS Code, we will create a module. We will write some function inside the module, and then we will enter into our Jupyter Notebook. From there, we will import this module, and then we will see how we are able to work with these scopes or names. Okay, so we'll begin. I am opening a root folder. This is my root folder. So here I am opening VS Code. So open with VS Code. So this is got open. So first what I will do here is I'll create a file. The name of that file is scopes.py. So scopes.py, that's how I have created, and I have written the file name. So scopes, capital S, it starts with. Scopes is the name of a file. So our module name is scopes. So now if I want to import this module, then I have to call scopes, import scopes. So now we can use scopes name to import, to call up or import when needed. So whatever we type here at the top level space of module are known as global scope names. So our global scope is this, with zero indentation, with no indentation. So X equal to 99, and the name X is a global space. And similarly, a function is also comes under global space. So X and func, the function name, both are assigned in module, both are global scopes. Now coming to the local scope, the implicit assignment, that capital Y, it's a parameter. This is a local scope. This is local to this function only. This is local to this function name func, func only. And when it comes to z is inside the function, so obviously z is also local to this function. Okay, so we have two global namespaces, a global scope capital X, and then FUNC, func, and capital Y and Z are local scope to the func. So this is my module that I have written. So I have one attribute and then one function. I'll save it. Now I will go to Jupyter Notebook and we'll start working. So our first example is scope. So what we will do here, we will import the scopes module that we have written as scopes.py file. So that's what I'm doing. Import scopes. And so now what we'll do is we will have a look at scopes module namespace. For that, what you have to do, you have to use dir inbuilt function, dir inbuilt function, and give argument as scopes. Let's execute and see. So the namespace is, this is a global scope. Capital X attribute is in global scope, and here we have our function. The in between, these are all inbuilt private variables. We don't need to bother much about that, but what you should understand is, this is how scopes helpful. See, only the global scope variables are visible or can be accessed directly. That whichever is there inside a function, whichever is enclosed inside the function, are not accessible. So that's the benefit. So this is our global scope attribute variable and this is our function. So now I want to access, I will use attribute reference expression. So scopes is our module, dot, and then func, the function or method inside that module, and I'll use one. So execute. I'll use 6 and do addition, that's 105. So this is how the global scope and then local scope helps us. So where you write your variable decides how you use in future, in your future programming. Now this module and the function, it contains a number of names to do their business. Now using Python scope or LEGB rule, we can classify the names as follows. Now I have taken the same function and then same thing whatever we have written there. So in this X is global because it is assigned at the top level of the module file. Then func, that function name, which is also global for the same reason. The def statement assigns a function object to the name func at the top level of the module. So you got the two global space names. So those are only accessible to the user, whoever wants to use that module. And we have capital Y and capital Z, which are local to that function and exist only while the function runs, because they are both assigned values in the function definition. Z by virtue of the equal statement, and Y because argument are always passed by assignment. That too, it's an implicit assignment. So obviously it is local. Now before entering into the second example, we'll have a summary. The whole point behind this name segregation scheme is that local variables serve as temporary names that you need only while a function is running. For instance, in the preceding example, the argument capital Y and the addition result z exist only inside the function. These names don't interfere with the enclosing module's namespace or any other function for that matter. So now we will go back to the VS Code and then we will write another module. The name of this module is nested scope.py. Okay, so what we will do here is enclosing scopes are sometimes also called statically nested scopes. Yes, absolutely right. Really, the nesting is a lexical one. Nested correspond to physically and syntactically nested structures new program source code. So this is, here we are majorly focusing on local and non-local scopes. So this is another example. This is high level or top level. Okay, top level of module file. So x is equals to 5 is a global scope, and as we have discussed earlier, multiplier, the function name, is also comes under global scope, and x in enclosing def. So this is an enclosing def. This is the main def, outer def. This is also called as enclosing def. This complete statement, because inside that there is a nested def na. So this is nested def and this is called the enclosing def. So remembers x in enclosing def local scope. So now this x is equals to 8 is local scope for this def. Fine, that's why it's called enclosing def local. This x equals to 8 is called enclosing def local. In legb, the e scope, L is local scope, E is enclosing scope, that is this scope. Then we have defined another function name, that is multiplication. Now this multiplication also local scope only. Multiplication is nested def, but that is local to the enclosing def. Okay, fine. And finally we have a y, which is an argument inside. So this is y is nested def local. This is y is local to this multiplication, whereas y is non-local to multiplier def, because this is enclosing def. This y is non-local to this. This is what I want you to let know here. So now we will go to the Jupyter notebook and we will import this. See here, what we have done is we have defined, we have placed variables at a certain places. So that means we have given scope. So now what we will do is we will go to the Jupyter notebook and we will understand how these scopes help us when we are programming, when we are coding. So now nested scope example. So here in this case, first thing we will do is let us import nested scope module that has been just written. Obviously this time what we'll do is import, as we'll import nested scope. This is the file name, module name as ns. Let's execute it. It got imported, and now we will access the namespace. The namespace is, we will use dir inbuilt function. So now if you see, you have only two names that can be accessed. Those are visible. Those are under the global scope. Whichever is in local scope and non-local scope, those are not visible to us. Now from the above namespace, it is clear that small x and multiplier are the only names are of global scope. Rest all are of different scopes. Now you can use attribute a reference expression that ns module name dot x attribute to get the value of that. And we will use the method name from the module ns. So we use method name, that's a multiplier, and then we gave value 14, and we'll get, but as there is a function inside it, obviously it won't give you the function directly. So now what we'll do, we will write a similar example here. The first one is here, the def, this def is called enclosing def scope, and the function name is prod, and this x is local to this prod or enclosing def. And second def, we have written a mult function, this is local def scope, and y is local to this a nested def, and you return x and y and return mult. So this is how the scopes are useful. Thus far we have seen local function def scope, enclosing def scope, and global def scope. But now we will look into built-in scope. With this we will be completing LEGB. This is how your Python searches from one scope to another. So now I just imported built-ins, and then I am printing dir of built-ins, so I will get. So these are the, number of built-in namespace. So like this, it will, the Python will search from local enclosing def, and then your global, and finally it comes to built-ins. If it doesn't find anywhere, it will throw an error. Now a name error, it will throw an name error. This is how you get that name error. This is how scopes are helpful. So mastering the scopes will always be useful for a good Pythoneer, a good Pythonist, or good programmer. So please practice it well, and if you don't understand, and watch it again, and if you still have doubts, just comment below. So I will respond it to you. And thanks for watching my videos, and keep watching the videos, and keep liking it, and keep spreading the word about this. And thanks, and I'll see you again, and in another video.